Hey yo guys, and for today's video we're going to be going over the radian conversion to degrees, and we're going to be converting degrees to radians as well. And finally we're going to do the special right triangle ratios, which are the 45, 45, 90, the 30, 60, 90 triangles. And before we start the video, please don't forget to subscribe and like our videos. It means a lot to us. Without further ado, let's begin. Alright, so we have our special right triangles and we're going to go over their ratios. As you guys know, there are two different types of right triangles, which will be the 45, the 45, 45, and 90 triangle, which we have right here. Let me turn the size down. And here 45, 45, and our 90 degrees here. And our special right triangle ratios will help us find what each side of our right triangle will be, and it shows the relationship between both sides. So here we have x and x and x, and we notice how these two sides are equal, making this a isosceles right triangle where there are two equal sides only. Here we have our hypotenuse, which will be equal to x to the radical 2. On to our next one, we have our second right triangle, which is a 30, 60, 90 triangle. And their names are derived from their angles, of course. So 30 degrees, 60 degrees, and 90 degrees. And like our 45, 45, 90 triangle, we will also have our ratios between each side, the relationships to each other. Here we have x to the radical 3, then we have x here, and then we have 2x. Now these ratios will come in handy for you in the future when you take your SATs. So it'll be like a really quick shortcut, and it'll also be helpful for you during your algebra 2 classes, as you will also be learning that. Okay, now moving on to finding a side using our special right triangle ratios. So first, on our left side, we have a 45 and 45, 90 triangle. Now, we know what the ratios are. This side is equal to a, this side is equal to a radical 2. This side is also equal to a radical 2. And then we are asked to find side AC, and we are already given side AB. Side AB is equal to 5. Based on the ratio, it is also equal to A. So then we can come to the conclusion that A is equal to 5. Now we know that side AC's ratio is A radical 2. So logically, we can plug our 5 in. So we get 5 radical 2. Side AC is equal to 5 radical 2. Now, moving on to our next one, we have a 30, 60, 30, 60, 90 triangle. We also know what the ratios for this one is. A radical 3 for the long side. As for our short side, it's going to be our A value. And for our long side, it will be 2A. So, we are first given that AB is equal to our 24. And let's say for this one, let's find BC. We know that BC is equal to A, and that side AB is equal to A radical 3 based on the ratios. Now, let's find what our A value is first. Let's plug in AB is equal to A radical 3. Isolate our A value, and we'll get 24 over radical 3. However, this is not the answer, as we must rationalize. A radical must not be a denominator. To fix this, we'll do this. 24 over radical 3 times radical 3 over radical 3. We'll be left with 24 radical 3 over 3 itself. Now we'll simplify, Well, we get that a is equal to 8 radical 3. We know that our b value is equal to a. So if a is equal to 8 radical 3, side BC is equal to 8 radical 3. Now on to our final segment, we'll be converting radians to degrees. Now a way that you can convert radians to degrees is by following this method, this formula right here, which is a radian times 180 pi. So we are asked to convert pi over 2 into degrees. So let's follow this. Put the radian in, pi over 2 into degrees, and we'll multiply by 180 over pi. We have pi on the bottom, so it'll cancel all the pi and give us a degree. And we'll get here, so we'll get 90 degrees. Because we have 180 pi divided by 2 pi, which is 90. Alright, so for this one, we have 2 pi over 3. 2 pi over 3. We take that and multiply that by 180 over pi. Okay, so then we'll get 360 pi over 3 pi, which will then be equal to 120 degrees. Now, instead of converting radians to degrees, we'll convert degrees to radians. Now, you guys can follow this formula here, degree times pi over 180, which is quite different from the formula for the radians, which is radian times 180 over pi. So let's go ahead and convert 180 degrees to radians. So we'll put our 180 in, 180 over 1 times pi over 180. You see that we get 180 over pi is equal to 180. So the answer 180 to radians is pi. Now let's do the same thing with our 150. Here we have 150 a degree over 1 times pi over 180. So now we have 150 pi over 180, which would then get us 5 over 6 pi. There we go.